something on structural concrete. So that's the analysis of singly supported rectangular section. So I have a worked example here. So analysis of singly reinforced rectangular section. We are supposed to determine the ultimate moment of resistance of the cross-section shown in the figure 4.7. Given that the strengths are Fy given to be 460 Newton per millimeter square for the reinforcement and FCU 30 Newtons per millimeter square, that's for the concrete. So these are the characteristic strengths. So here we have the section, the rectangular section, and this is the reinforcement. We have the distance from the top to the position of the reinforcement. We have it 520. Also have B, that's the breadth, 300 millimeters. And then here from the top, this point, that's the neutral axis, we have the value of x, and then the value of s in the stress block here. So we start the value of s start from this point up to the end of this rectangular section in the stress block here, and then c, that's the distance from where the force act here to the position of the reinforcement. So for equilibrium of the compressive and tensile forces on the section, we have the value of compressive forces. It's the same as the tensile forces, that's the equilibrium. So the formula for calculating the compressive forces is 0.45 FCU, that's the characteristic strength of the concrete, then you multiply by BS. So we have the value of B here. The value of B here is 300, and the value of S, we're going to look for the value of S we don't have here. So for us to get the value of S, we're going to equate the two equations. This is the formula for calculating the tensile forces and the stress block. So we have 0.45, you multiply by FCU. FCU here we have it to be 30. Then Fy, that's for the reinforcement, 460, then for the concrete 330. So you can substitute in the equation here. And then you make S the subject of the formula. Fy is 460, As we had it already. The value of As, that's the area of the tensile area here. Is 1470. So substituting the equation here, we'll make this as the subject of the formula. So we're going to divide 0.95 by 460 by 1470, you divide by 0.45 by 30 by 300. So the value of S here will be 159. Then for us to get the value of X, the value of X here is from this point here up to the neutral axis. So the value of X, say S is the same as 0.9x. So you make X so because we have already the value of S, so we're going to divide by 0.9. So the value of S here is 159 divided by 0.9, you're going to find the quantitative value of X. That's 177. This value is less than the value of 0.6615 D derived from the section 4.2. Therefore, the steel has yielded an FSD is 0.95 Fy as assumed. So moment of resistance of the section will be, but first Basing on this, for analysis of a section with non-steel strains, the depth of the neutral axis can be determined using this formula here. So at the ultimate limit state, the maximum compressive strain in the concrete is taken as 0.0035. So for steel with F4, I just take a characteristic strength of the reinforcement. We have a phi being 460. The yield strain is 0.00219. And citing the values in this equation here, you're going to find this as 0.615D. Hence, to ensure yielding of the tension steel at the ultimate limit state, X should not be greater than 0.615D. But here we got the value of X being less than that one. Okay, so meaning it has yielded because the value of X should not be greater than 0.615 then. So moment of resistance of the section. So for us now to find the moment of resistance, because the question ordered us to calculate to determine the ultimate moment of resistance of the cross section of this cross section here, this one. So using this formula for calculating ultimate moment resistance of a rectangular section, that's moment is same as forces. So there's tensile forces, you multiply the distance c. So the distance c is from this point here up to this point where the tensile force is at the level of the reinforcement. So doing the multiplication here, because you already have the value of c given here, okay. So for us to find the value of c, we're going to use this formula as d. You subtract s, you divide s over 2. So substituting, already have the value of d. The value of d here is 520. So we have 520 value of d. So substituting in the equation, we're going to find the value of z, which would be this d, you subtract the value of s here over 2. That's up to this point here, where the force acts. So substituting the whole formula here, so we have the formula for calculating moment of resistance of the section pin m, same as tensile forces multiplied by this value of z. So it's 0.95 FOI. We already have the characteristic strength of the reinforcement being 460. Then you multiply by the area of the tensile section. So we had it already being 1470. Then you multiply by the value of c here. So you're going to get the value of moment of resistance of the section being 287 kilonewtons with this. So thank you for watching this end of the tutorial.